Hi, everybody. We're still in linear functions. This is section S for IXL Algebra 1. And I was doing S16 yesterday and couldn't do it. I had a bunch of lags, so I'm going to try today. Anyway, it's comparing linear functions, tables, graphs, and equations. So I didn't even get to preview it much. I only got to see a few problems. Hopefully, I'll like them as much as I think I will. Let's see what we got here. Aha. Okay, they want me to compare the slopes between the table and the equation. So the trick here is to find the slope. Now, a lot of people are going to automatically just grab their slope formula, which is, of course, m equals y2 minus y1 over x2 minus x1. But another way of thinking of this is that it's the change in y over the change in x. Now, what I'm going to do is I'm going to go ahead and do this the standard methodology, which is to choose an x1 and a y1 and an x2 and a y2. It doesn't matter which point you put where. As far as assigning them point 1 and point 2. It doesn't matter which one you pick for point 1 and point 2, but it does matter that you don't mix them up. Like you can't put x1 with y2 and so on, or you'll have a sign error about half the time. So y2 minus y1 is going to be 25 minus 5. Now, it's always a good idea to substitute inside parentheses in general. So I'm going to do it that way. And now I'm going to take my x2, which is the 5. What I was talking about is that it's important that you go in the same order that you chose in the initial one. And of course, we've got 20 over 4, which is 5. Now, that's the long method. But the way that I like to think about it is I like to think of it as how much did y change over how much did x change, which is the change in y over the change in x. So here's what it looks like. From 5 to 25, I went up 20. And from 1 to 5, I went up 4. And when I look at this change, 20 over 4, it's a change, it's a slope of 20 over 4, just like before, or 5. In other words, I can see this subtraction in my head for me a lot easier than I can go through all of those steps. So there it is. I don't want to kill it. Of course, the equation is y equals 5x something, but we're interested in comparing the slopes. So the slope of function b is 5, the slope of function a is 3. So function a is a smaller slope than function b. Nothing like over teaching, huh? Well, hopefully we'll be able to do it a little bit quicker now. So this change was up 12. If you need to see it, you can go ahead and subtract it on the side. But hopefully you'll be able to see this a little bit easier. And this one went up 3. So my slope was 12 over 3, or just simply 4. Now I could do the other pair in just a minute, I'll do it. But I want to compare it with probably the slope of function b, which looks a whole lot like a 1. Whenever you see the change in y is equal to the change in x, it's a slope of 1. In other words, I went up 4 to go from here to here. I went up 4 and I went over 4. And 4 over 4 is a slope of 1. Whenever you see it going through those diagonals, this is your standard equation. Y equals x. And then, of course, it was a minus 4 because there's your y-intercept. Anyway, this one has a slope of 1. This one has a slope of 4 over here. And of course, function a has a much larger slope. So let's see. There it is. Okay, we're going to speed it up as we go along. So hopefully you paid attention. Oh, and I forgot to do the other slope. All right, well, I'll do it this time, I promise. So we went from negative 10 up to 6, which is an increase of 16. And from negative 8 up to 8 is an increase of 16. So this one has a slope of 1. So function a has a slope of 1. But they are asking about the y-intercepts. If you look down here, they want to know about y-intercepts. I still need the slope, though. And I'll show you how I'm going to get that in a minute. Well, the y-intercept in this one is at 0, 5. Now, they're thinking of the y-intercept as being the value of b so that they can compare the values. But the y-intercept is actually a point. Like I said, more information than you wanted. All right. I'm going to go ahead and do function A very formally, and then I'm going to show you the informal method as we go along. But the formal method that you would probably want to do is mx plus b, y equals mx plus b, and you're going to choose one of the points. It makes no difference at all which point you choose. I'm going to try to avoid the negatives, so I'm just going to go ahead and pick this bottom point. Doesn't matter which one you pick. Y is 8. M, like I said, is 16 over 16, which happens to be 1. The x is 10 plus b. And when I subtract 10 from both sides, I get negative 2. So my b value is negative 2 for function A. Now remember, that's really not the y-intercept. The y-intercept is a point, which is 0, negative 2. But they want me to compare the b's. So negative 2 is much less than 5. And we could graph it and everything. It's going to look like this. It's going to go like this. It's a slope of 1, isn't it? So they might even ask for the intersection. So there you have it. We wanted to compare the y-intercept values, and A is much smaller than function B. Way too much information, isn't it? All right, now this time I'm going to remember. I'm going to show you the slope, and one of the things I like to do is do it more than once in case I make a silly error. Now to go from negative 23 up to negative 11, I went up 12. If you can't see what I'm doing, take negative 11 minus negative 23. Do the subtraction and you'll see. From negative 10 to negative 4, I went up 6. So this is a slope of 12 over 6, or 2. Now I wouldn't have done that step. I would have just done it in my head. Now I want to show you. It's going to be the same slope on the next pair. Take a look. From negative 11 up to 5. Can you see how much I went up? I went up from negative 11 up to 0, and then 5 more. So that made 16. That was my change. And from negative 4 up to 4, I went up 8. Now these numbers aren't the same, but their ratio is. You see 16 over 8 is also 2. And that's what tells me that these are on a line. And if you were ever asked, is the function b linear, that was the way that you would do it, is you would compare the slopes between the first pair and the second pair. And if they're all equal, then they're in a line. The slope of function A is equal to 1. And of course, they did want me to compare them. So function A has a smaller slope than function B. All right, now that was a lot of stuff, but here's why it's going to be important, because I can do this very rapidly, and I'm not just putting numbers mindlessly into a formula. I want to think about how much did this change, and it changed by 28, and this one changed by 14. So this is a slope of 2. Let's do the next pair. This one went up by 8, and this one went up by 4, which is also, of course, a slope of 2. So the slope is 2 for function A. So function A has a slope of 2. Function B, of course, the slope is just 1. It's the coefficient on that x. Remember, if you don't see a number in front of a variable, there is automatically a 1 there. There also happens to be a 1 in the exponent, but anyway. I would like to show you a shortcut for this, but I'm just going to show you the long way one more time. And then if there's a nice shortcut available, I'll try to show it to you next time. I could do this very quickly. Think about counting backwards the slope and finding what's in between these 2 points, the first pair of points. If you can discover it for yourself, it's much better than me just telling you what it is. But I'm going to go ahead and choose my middle point, and I'm going to do y equals mx plus b. And what I'm looking for is that b value. They call it the y-intercept. So y is going to be 12 for that middle point, and my m is 2, and my x is 6. And it's not very interesting. Look what happens. This subtract 12 from both sides, and b is equal to 0. So the equation for function b is y equals 2x. And take a look. Negative 8 doubled is negative 16. 6 times 2 is 12, and 10 times 2 is 20. I know absolutely for certain that this one is a direct variation. That's what that's called. Or we can say that y is proportional to x. That's another way to say the same thing. So we're comparing the y-intercepts. Well, this one has a y-intercept, a value of 0. This one has a negative 5. So A is larger. Again, got to be careful. Negatives are smaller than 0, aren't they? So the y-intercept of A is greater than the y-intercept of B. Way too much information, isn't it? All right. So I'll try and keep it down a little bit. So this one went up 18, and this one went up 6. So this looks like a slope of 3 for function A. I didn't even look at the y-intercept yet because you really need the slope before you can do much of anything else. The rate of change is a really important concept. It also determines your linear, if it's linear or not. And we can look at the next pair in just a minute if you want. We are just comparing the slopes. So let me just go ahead and do the other pair as well. Can you see that this one went up 24? You had to go up the 5 and then 19 more. And then this one went up 8. And 24 divided by 8, I know, yeah, it's 3. Anyway, the slope for function A is 3, and the slope for function B, what you want to do is you want to pick some intersection points. So you got to look kind of carefully at the graph. And I have an intersection here at 0, -2, which of course is my y-intercept value. And I'm going to go up 1, 2, 3, 4, 5 over 1. Be careful. Some people are going to do the following, and I see this a lot. A lot of students, when they want to count their slope for any equation, they start counting from the origin. And you can imagine why that would be the case. And if you were to count from the origin, you would think that maybe these two have an equal slope, which they certainly don't. This one is going up much faster than 3. Anyway, the slope is 5 over 1, so the slope of function B is larger. Let's see what they asked. And function A is less than the slope of function B. I know I'm going really slow. I'm sorry. I'll try and speed it up a little bit. This one went up 5, and this one went up 1. Oh, there's a slope of 5 as well. And notice this one went up 20, didn't it? And this one went up 4, which is also a slope of 5. So this one has m equals 5. Now, they ask about the y-intercepts. Let's see. There's no real nice way of doing it other than to just put it in. I think that's going to be the easiest way for you. So we're going to do y equals mx plus b. Just try and pick an easy point. And I like the 1, 8. So 8 is equal to 5 times 1 plus b. Subtract the 5 and you get b equals 3. So this equation for function A is, of course, y equals 5x plus 3. This is function A. I'll label it. There we go. And we want to compare the y-intercept values. This one is 3, B is 4, so function A is less than for function B. All right, we went up 6. And we went up 6. This one has a slope of 1. And we want to compare the y values this time. Now, they didn't tell me what 1 was equal to for function A. So I'm going to need the equation of function A in order to find out the value when x equals 1. Basically, here's what they're asking for. They want to know what is the value of function B and function A when x is equal to 1. And the way that you do that is you substitute 1 in for x. One way to write this function is like this. F of x equals 5x plus 4. There is absolutely no difference between the y and the f of x. Now, the way we write when x is 1, oh, sorry. I knew that was going to, I shouldn't have touched it. So we'll do another one. I'm sorry, I shouldn't have messed that up. I should have substituted the 1 in, found the equation, and compare the two. Darn, hate it when that happens. All right, so let's see. They're asking for the slope comparison. Darn it. All right, this one went up 14 and this one went up 7. So it has a slope of 2. That's what I get for overteaching. This one, we started here and I'm going to go up to here. It looks like it has a slope of 1, 2, 3, 4 over 1. So this one has a slope of 4 and the slope of A is less than B. I'm going to move right along here and catch up with my dumb mistake there. All right, this time they're asking about the y-intercepts. Function A intersects the y-axis at 0, 5. So my B value is 5. I'm just going to talk about the B value. For function B, I want to mention something. If this is a linear function, the midpoint of these two, the number right in the middle of them, is going to be your 0. That's going to give you your y-intercept value. That would be a way of finding it, is to find the midpoint of those. And all you need is the average of the -9 and the 11, which happens to be 1. If you add them together and divide by 2, you get the midpoint. The midpoint of these two coordinates is 0, 1. It was just a shortcut. Now, of course, I could go through all the steps and mindlessly just put the numbers into the formula, but I don't want to do that either. I'm going to go ahead and find the slope and just show you how to find it another way. The slope here, I went up 10, and on this side I went up 2. So this has a slope of 5. And I'm going to substitute y equals mx plus b, and I'm going to find the b value. I'm going to use the 211. 11 is equal to 5 times 2 plus b. And we subtract the 10 from both sides and get b equal to 1. Either way, it doesn't really matter which one you use. I kind of liked this shortcut, just happened to see that it's right in the middle of those two. So anyway, we're comparing the y-intercepts, and function A is greater. Here it is. Here we go. Okay. So the one that I messed up for you, they want to know what happens when x equals 3. So what I need is a function equation for both of these. Now this one I don't actually, because I can look right on the graph and see that when x equals 3, it's right there. And there's my y value, 2. So basically they're asking for the point 3, 2. And they want to know what is the y value when x equals 3, which in function A is 2. It's really nice that you have a graph there because you can always just look it up. Now this one is a lot more complicated because you're going to have to find the slope, the y-intercept, write the equation that goes for it, and then, and only then, will you be able to find the value of 3. There is another way though. Can you think of how I did it last time, my shortcut? Did anybody notice that 3 is right between 1 and 5? Well, if you take the average of 1 and 5 and you get right in the middle, the average of those two numbers is 3. And the average of these two numbers, 1 and 17, is 9. So I happen to know that the midpoint of those 2 points is 3, 9, and it's definitely going to be on my line. So the y value is 9. Now that would be the shortcut if you happen to see it. If you didn't happen to see it, or there's no way and they didn't give you the right kinds of points in order to do it, then you have to go through all the steps, which is to find the slope. From here to here, I went up 24. And from here to here, I went up 6. And this one has a slope of 4. So function B has a slope of 4. And I'm going to use this point because it looks really easy. So y equals mx plus b. And I'm going to subtract 4 from both sides. And I'm going to get b equals -3. And I'm still not done because I still have to put in the equation, don't I? Well, the slope is 4 and the b is -3. So I have y equals 4x minus 3. And what am I interested in? I want to find out what happens when x equals 3. So substitute 3 in here and we get 4 times 3. I'll go ahead and substitute it for you. -3, which is 12, minus 3, which is 9. Now that seems like a whole lot of work compared to this one, doesn't it? That's because if you turn your brain off and you don't think about it, you're going to have to go through all the steps every single time. But when you can see a nice shortcut, sometimes it's nice. Anyway, my y value in function b is 9 when x is equal to 3, and my y value in function a is only 2. Let's see. The y value of function a when x equals 3 is less. So there it is. Quite a bit of stuff going on there. I'll show you another shortcut in a bit. We're doing slope this time though. So -3 to 4 is a change of 7, and from -10 to 4 is a change of 14. Now be careful. A lot of people are going to see that 14 and that 7 and say it has a slope of 2. It does not have a slope of 2. It has a slope of 1/2. Remember, it's always y over x. Now this one went up 2, and this one went up 4. And again, you're going to see that 4 and that 2. Remember, it's 1 over 2, 7 over 4, or 4 over 2. Sorry, 2 over 4, dummy. There we go. Okay, so it's 1/2 anyway. There's the slope of function A. Function B, we're going to have to count. So there's 1 point, and there's another point. And hopefully you can see that this is 1/3. Now the question is, which one is bigger? Well, 1/2 is 0.5, and 1/3 is 0.33333. Most people have an easier time comparing decimals than they do fractions, but visualize 1/3, and you know that if you're going to divide one thing among 3 people, they're each going to get a smaller part, aren't they? So the slope of function A is greater than the slope of function B. Lots of stuff going on. Okay, let's see. The Y-intercepts, we want to compare them. Well, there's one of them, 0, -2 for function A. My B value is -2. Now for function B, I don't have a nice midpoint this time where I can get the 0 value. I don't see any easy way to do it. Although I want you to notice something. From -5 up to 13, we're going to what? What's the difference here? Well, that's going to be, I went up 18, and from -5 to 4, I went up 9. So what I'm doing really is counting by 2s, aren't I? N equals 2. And if I count back by 2s, this is going to be a really weird one. So I don't see a nice, easy, I don't see a real easy shortcut for this one. So I'm going to go ahead and substitute it into my y equals mx plus b. And I'm going to use this one, 413. So 13 is my y value, 2 is my slope, 4 is my x plus b. I'm going to subtract 8 from both sides. And b is equal to 5, isn't it? Got him? And if b is equal to 5, and this b is equal to -2, the a is much smaller, isn't it? Okay. The y value when x is equal to -2, I want to compare the y value at -2. Now, I know I showed you some shortcuts before, but I'm going to show you the super shortcut now. We're interested in what happens at x equals -2. And I want you to think about this for a second. If this is a linear function, what is the point at -2 about? What's it close to? Well, I want you to notice that we know it's really close to this point, isn't it? It's going to be really close to 3. In fact, it's probably right next to 3. It's probably a little bit smaller. I'm going to guess that it's probably 2 based on this function, just looking at it and estimating. I'm going to say that it's really close. So I'm going to say it's approximately 2. Now over here, I'm looking at what happens to the graph at x equals -2. Well, there's my -2 value, and look at the y value. It's way down here at -8. This one has to be much, much larger than this one, clearly. And using estimation is a really important tool. Look how simple that was. I looked at -2. I estimated where my y value was going to be. I looked over here, and it looks like the y value is going to end up being positive. So I am going to say what? That the value of the function at x equals -2 is much, much larger for function a. I gotta make sure I'm reading it correctly. Yeah. So I just used estimation. The slopes. So this one went up 10 and this one went up 4. Interesting. 5/2, huh? This one went up 15 and this one went up 6, which is 5/2. So the slope over here is 5/2, which is 2.5. And the slope over here is 1/3. So the slope of A is greater than the slope of function B. Now the y-intercept is the one we want to compare. Well, this one is 1, and the y-intercept here is in between these two, isn't it? So clearly the y-intercept of A is greater than for B. I'm estimating. There it is. Done. I hope you got that. Let's see. We're talking about the y value at -8. Okay. Think about this for a second. I'm going from 4 to -4 and from 8 to -4. Now, what I want to do is I want to estimate what happens to function b at -8. So I'm just going to guess right off the top of my head that if moving this one is gives me a negative, -8 is going to be even more negative than -4, clearly. So I know that it's quite a bit more negative than -4. So I know it's going to be smaller than -4. Now over here, I get -8. If I substitute it into this function, I get y equals half of -8 plus 1 is -4 plus 1, which is -3. And look what happens. This y value is going to be -3. This y value is going to be much smaller than -4. So A is larger. All right, guys. Try some of your estimating, and I'm going to go fairly quickly through the rest, and I'm going to try and make it really easy. Now I'm looking at the y-intercepts. Now the y-intercept is between these two, isn't it? And the y-intercept of this one is at -1. So A is going to be larger. Come on. Oh, submit. Oh, I was supposed to choose them all. I should have checked my my line more. There were maybe some more possibilities. Sorry about that. So function A and B are linear functions. Select all that are true. Well, I am going to go through and select all the ones in just a second. I'm going to try and pause my video for a second here. I'm going to see if I can pause my. Okay, I think that worked. Wonderful. I wanted to have a way to pause my recording if I had a phone call or I had somebody interrupt or whatever. So hopefully it worked out. So I'm comparing the slopes, and I'm also looking at y values when x is equal to 4. So I've got a lot of things to look at here. Probably the best thing to do is to go ahead and get my equation for function b. It's going to be a lot easier if I do that. So that's going to be my first step, is to find my equation. Be careful. A lot of people are going to look at this very first point and say, oh, a y-intercept. That happens to be an x-intercept. -10, 0 is on the x-axis. And you know how I can tell? This is a really important idea. The -10 is an x value, isn't it? The 0 is the y value. And whenever you see an x value with 0, you know that it's an x-intercept. It's on the x-axis. Okay. We wanted to look at the slope. So let's see, we went up 1, and in this one we went up 2. For this one we went up 1, and for this one we went up 2. Of course, this is a slope of 1/2. So the slope of function b is larger than the slope of function a. Function a is less than the slope of function b. Now, what they're asking for is for me to choose all the statements that are true. So I need to keep looking for any other true statements. Obviously, the function a slope is not greater. The y value when x equals 4, so those are the ones we want to compare. I could use what I call interpolation to figure this out, but I think I'm going to go ahead and find the equation. It's going to be easier for most of you. For this side, if I'm interested in x equal to 4, I need to substitute it in. 1/4 of 4 minus 2. 1/4 of 4 is 1. Some people are going to think, oh, I'm going to simplify it. 1 minus 2 is -1. So the point is 4, -1 for function A. Now I still need function B. I happen to know that the slope is 1/2, isn't it? And I'm going to write y equals 1/2 times x plus b. I should have put in I should put the parenthesis there. I'm just doing my y equals mx plus b business here and choosing a point. Now, a lot of times I like to choose a point that doesn't have any negatives in it, but I don't have a choice here. But I want you to notice something. I could choose this one, but that's going to give people, I think a lot of people are going to have an issue with that one. So I'm just going to I'll pick this last one here. So I have y is positive 2, x is -6, and I am going to multiply that. That's -3 plus b is equal to 2. So b is equal to 5. So my equation for function b, get rid of these little dots here. My equation for function b is y equals 1/2 x plus 5. And we want to substitute in 4. And when I put a 4 here, I'm going to get 2 plus 5 or 7. So 4, 7. Clearly, this one has a much larger value than the one for function A. So function B is larger. Let's see what it says about it. The y value of function A when x equals 4 is equal. Nope. The y value of function A when x equals 4 is greater than function B, and it's not. Neither one of these is true. Now, be careful. A lot of people are going to get to this one, and they're going to say, oh, they're not equal, so it must be the other one. That's the mistake that they make. None of these other 3 statements are true, so I have to submit the way it is. That's probably what happened when I didn't see the extra at the bottom. All right, so it looks like we want to compare these two, and we want to compare the slopes and the y-intercepts. Again, a lot of people are going to mess that up because that's an x-intercept, not a y-intercept at -10, 0. All right, so let's take a look at the slope. It went up 3, and this one went up 15. So this is a 1/5 slope. If you need to see it, it's up 1 and up 5. That's 1/5. So the slope of function A is 1/5. The slope of function B is 2/5. So clearly, the slope of function A is not equal, and the slope of function A is not greater. So neither one of these two, this one's no good and this one's no good. Now we want to look at the y-intercepts, and we want to compare them. So for function A, I'm going to use my 5, 3 point, and I'm going to use the slope is equal to 1/5, and I'm going to substitute into y equals mx plus b, and yada, yada, yada. The y is 3, the m is 1/5, the x is 5 plus b. The 5's cancel out, give me 1. I'm going to subtract 1 from both sides, and I'm going to get b equal to 2. So my equation for function A, this is function A, by the way, is y equals 1/5 x plus 2. And we are interested in the y-intercept, which they're considering to be the 2. And for function B, it's 3. So function A is less than for function b, which is true. And function a is greater than function b. No, that's the only true statement out of all four. It's actually harder when there's more false statements, isn't it? All right, let's see if we can do a little bit of estimating this time. Let's see. Okay, we're supposed to choose all the true statements, and they want to know about y-intercepts and at x equal to 4. So I'm just going to put a little, I'm interested in comparing these points, and I'm also interested in comparing these points. I'm actually comparing the y values when x is equal to 0 and the y values when x is equal to 4. So I want to compare these two. I only care if I know which one is larger for the most part. They might have said something about being equal. Well, the first thing I'm going to do is let's see. I can't do a nice average here. If I knew what -1 was, I could do the average between those two, but I can't. There's a way I could do it, but I'm just going to go ahead and do the slope and go through the steps. This went up 1, this one went up 4, this one went up 3, and this one went up 12. So of course, 3 over 12 or 1 over 4, same thing. So the slope of function b is 1/4. The slope of function a is up 1, 2, 3 over 2. So the slope of function a is 3 over 2. Clearly, function a has a much larger slope than function b. So that's our first, we've done the first part. So let's take a look and see which one it is. The y-intercept and the y-intercept. Oh, and the y values. Oh, we didn't need the slopes. We needed the y-intercept. The y-intercept for this one, sorry, is at 0, -1. And the y-intercept for this one, we're going to have to find it. So we have y equals mx plus b. We're looking for b. And y is, let's use this one, 1 equals 1/4 of 8 plus b. This one, we're going to subtract the 2 from both sides. 8 and 4 simplify to give you 2. I'm going to subtract the 2 from both sides and get b equal to -1. So my equation for function b is y equals 1/4 x minus 1. Oh, so they have an equal y-intercept, don't they? So the y-intercepts are equal, first of all. So we got that one. This one is out. Now we want to compare what happens at 4. Now let's see if we can estimate. Oh, look at that. It looks like it's going to be closer to 1 over here than to -2. Does everybody see that +4 is closer to this point than it is to this point? So if I had to estimate, I would say it's somewhere around 0, because from -2 to 1. Let me erase some of this so you can, nah, that's all right. I want to see what happens to this one at 4. Well, at 4, look at this. 1, 2, 3, 4, 5. This is 5. And so this point is 4, 5. I absolutely guarantee that this value for 4 is between 1 and -2. We know that it's, and if I had to estimate, I would say it's probably 0. And it almost certainly is. Look over here, we have a 5. So obviously function a is much larger than function b for the x equal to 4. Function a is not less, and function a is greater than function b because it's at 5. And that's it. And it looks like we have one last one. And I'm going to try and do it a little bit quicker here for you. I'm sure you want to get this done. So first of all, let's take a look at our question before we start. So we're interested, what happens at x equal to -6? So basically the question is, we want to compare the y values for both of these at -6. The other thing we want to do is compare the y-intercepts. So we want to compare what happens to the y values at 0. So let's see if we can make it really, really easy for you. First of all, at 0, this one is going to be -4. And this one at 0 is going to be about 3. I'm just estimating, okay? I know it's probably not exactly right, but I'm going to say it's about 3, okay? So obviously, function A has a much larger y-intercept. So let's see. It's certainly not equal. It looks like function A has a much larger y-intercept, just based on just looking at it. Now, at -6, this one is going to be between these two. You see what I mean? This one, for -6, if I substitute it in, can everybody see I'm going to get -6 out? If you need to see it, it's this. I'm putting y equals 1/3 times -6 minus 4. This is -2 minus 4, which is, of course, -6. So that's my value, -6 over here. And this one, for -6, is between these two. Clearly, this one over A is much larger than for function B. So A has a larger value than B. And we're done. Hopefully you can do some estimating, and it's going to save you a lot of pain and trouble for having to solve the equation and substitute and turn your brain off. So I hope you enjoyed them. And there it is. I know it's right. And have a good day. I'll see you back. Bye.